Okay, so in this class now we're going to look at GIF. Sometimes pronounced GIF. Nerds in bars will argue over which is correct, GIF or GIF. I think actually GIF is probably correct, but I think most people in Ireland call it GIF. I think anybody who calls it GIF is maybe just being a tool, but I think GIF is actually correct technically. Okay. So graphics interchange format was the main image format on the web for a long, long time. So back in the day when I was at college, an image on a computer screen, which you might have got by email or FTP'd, even before the web, would have come as a GIF. You even had animated GIFs, there was even animated GIF porn in the day. Now, it's kind of quite a tired format now, and it's not the format of choice. It's quite limited, as we'll see, but it has a very long heritage. So, GIF uses at most 8 bits per pixel, which of course 20 years ago was plenty. It's loads. I mean, you couldn't get a monitor that would display more than 256 colors anyway. So hey, okay. The compression in GIF is lossless. Now, of course, that's only kind of true. I mean, if you take an image that's in 24-bit color and you save it as a GIF, well, you're going to have an awful lot of loss. But the loss is in going from the 16, 17 million colors down to the 256 colors. Once you've got 256 colors, after that, there isn't any more loss. Okay? And that's a reasonably important feature of GIF, actually, as we'll see. So one color can be transparent. So in GIF, one of the pixel values can be invisible. And there's a progressive option, and you can also have animated GIFs, which are interesting. So GIF then turns out to be ideal for logos and graphics and buttons and stuff like that. You don't see many buttons anymore, actually. You don't see buttons on web pages anymore. But so if it doesn't have too many colors, GIF is fine. When you start doing your experiments, you see that very often 256 colors is plenty, depending on the image. And the important thing about GIF is that once you're in 256 color land, there's no further loss after that. So for something like the CIT logo here, GIF is perfect. But people generally don't consider GIF as even an option. It's just presumed to be inferior, when in fact it may be superior for the kind of image you're dealing with. So if it's graphic, if it's a cartoon or a drawing or plans, wherever you have sharp edges that you want preserved, GIF is superb at that. So if you have a buddy who's a cartoonist and he wants to put his pictures on the web, GIF might be fine for that. We'll see when we look at JPEG, which is another format and by far the most popular format, that JPEG is particularly bad at the things GIF is particularly good at. So often in CIT, for example, you'll see the logo stored as a JPEG and the color is a bit dirty or mucky or whatever, So, so looking at an image, you should even be able to say, that's a good candidate for a GIF. Or maybe you look at it and think it's a bad candidate for a GIF. But you should be able to make that kind of judgment. Obviously, going from 16 million colors to 256 is a bit of a drawback, but it may not be huge. I mean, if you look at these logos here, the old CIT logo and the new CIT logo, you know, there's maybe 30 colors at most on a good day. This is probably just has maybe 4 or 5 colors. You don't see them there, but there would be intermediate shades of red where the white and red meet. It's to give it a kind of a smooth look. If you were to look at the actual pixels, you'd find there's not just red and white there, there's sort of pink at the edges. We call that anti-aliasing as it happens, and that would give you a smooth edge. And this might have, you know, 30 odd colors, whatever. Certainly, if you only had 256 colors to play with, either of these logos would be fine with that. Now, so GIFs can support transparency. So one of the values in the lookup table can basically say transparent, which means you can see through it. So that can be useful in certain situations. Back when people made hideous web pages, it was often very popular to have a background image on a web page rather than just a plain color. And if you had a transparent GIF, you could see through the image onto the background. So if this image on the right here that doesn't have the transparency, that would only look okay on a white background. Whereas here you can see through this onto the background. Now, the transparency that's supported by GIF isn't very sophisticated. A pixel can be completely transparent or not. Because of this anti-aliasing thing actually I talked about, where you might have intermediate shades in between, it very often doesn't look very satisfactory. It's not always that you would have a nice crisp edge like this to work with. So even though GIF does support transparency, it typically isn't great. GIF supports progressive coding. So what's that? Well, GIF is very old, and when GIF was in its heyday, the internet was very slow, the web was just starting, and so downloading images was something that took a while. You would actually see the images downloading before your eyes. Now they appear instantly, and so we just assume they're there as part of it. But when you download a web page, the HTML comes first. It sees that there might be images in there, and then the browser has to go off and download the images from the server, and those then arrive, and the page lays them all out. We have the illusion of everything coming instantly now, unless you're on your phone and you don't have 3G service somewhere and you're just back to ye olde data. It can be a bit slow. So progressive coding allows the viewer to get an impression of the entire image before all of it is downloaded. So instead of, like at the halfway point, instead of seeing half of the image, you might kind of half see all of it. And that's very useful where you have someone waiting for the image to download. It doesn't actually, progressive coding doesn't actually let it arrive any faster. It's still, in fact, often it's slower as a result, but the wait doesn't feel as slow. So I'll explain now what I mean by that. So when you're downloading something normally, or if you were downloading a regular GIF, you know, as it's downloading, more and more of it gets revealed. So at the halfway point, you like see half of it. Okay. But I mean, it's hard to imagine now, but back in the day, you know, a long time ago, it might have taken a minute, you know, for the whole image to download. And a minute is so long in 2015 that really I couldn't even simulate that for you now and make you stand there and look at it for a minute, because you would just freak out. You'd be shuffling in your seats, you know, just be really, really slow, you know. But it was a long time. You'd be sitting there and the images would download. With progressive downloading, what happens is you get an overall vague impression of the whole thing first. So it might look something like this. And then with time, it becomes more resolved. So at the halfway point, you can half see all of it instead of fully seeing half of it, if that makes sense. And so then with time, it would finally appear. Now, so how does GIF do that? It turns out it's actually clever, but not terribly sophisticated. It's actually quite easy to understand. So under normal circumstances, you would expect GIF to code pixel by pixel like that, right? Do the first row of pixels and then go on to the next row of pixels and then go on to the next row of pixels till you're done at the end. So by default, GIF would code the pixels in the same order that we would read in English. So you start at the top, you read a line, you go on to the next line. So you're going from left to right, top to bottom. When it's in progressive mode, what it does is it skips ahead. So it does line number 1 and then line number 5. And then line number 9. So it would do every 4th line. And then when it gets to the bottom, it would go back up and start again. And incidentally, then it does line 2 and 6. I think it would have been better if it did line 3 and 7 next, but it doesn't. And so it fills up this way. So at this point, you would have a quarter of the pixels, but they'd be spread out from the whole image, so you'd get a feel for what it might look like. So the viewer can do two things, and I've seen both in my time. One way is it can just show you those, like you might start with a big black box and then show you the lines as they appear, you know, and so it eventually appears line by line. Or you could decide, look, all these 4 pixels here are going to have the same value as this one here. So it would be sort of blurry. And then as more data comes in, it becomes less blurry. That's another approach. Oh, okay. Thought I had a bit more to say about that, but I don't, it seems. Okay.